Welcome to qnawire.
Okay, so we know the relationship between the changing area and the changing velocity can be expressed with such equation here, which is dA over A is equal to negative dV over V times 1 minus ma squared. So we know the velocity is a subsonic velocity, which means that Mach number is less than 1. If Mach number is less than 1, that means 1 minus ma squared is greater than 0. So 1 minus ma squared is positive. And we know this is a diverging duct, which means that the area is increasing, which means that dA is greater than 0. So therefore, in order to maintain the equation, dV must be less than 0, since there's a negative sign before it. So since we know the left side must be positive, since dA is greater than 0, and we know the area is always positive. So therefore, left side is positive. So in order to maintain the equation, the right side must be positive as well. We know 1 minus ma squared is positive. That means negative dV over V must be positive as well. So in order to make the term with a negative sign become positive, that means dV must be negative as well, since we know the velocity is not negative. Okay, so therefore dV is less than 0, which means that it's negative. So it indicates that the velocity is decreasing. And for the next question, so we know dV is less than 0, which means velocity is decreasing. If velocity is decreasing, that means the kinetic energy is decreasing. If kinetic energy is decreasing, that means the internal energy is increasing, according to energy conservation law. So we know the temperature is associated with the internal energy. If internal energy is increasing, that means the temperature is increasing. So therefore, temperature will increase in this case. And for the next case, so this is the relationship between the changing area, and the changing pressure. So we know subsonic velocity will lead to ma is less than 1, so therefore 1 minus ma squared is greater than 0. And then we know diverging ducts lead to dA is greater than 0. So therefore, in order to maintain the equation, dP must be greater than 0, since all the elements here are positive. So dP must be positive as well. If dP is positive, that means the pressures increase. So for the last case, so this is the relationship of the changing density, changing area, and the changing velocity. So let's divide it by dV on each side. So we have d rho over dV times 1 over rho plus dA over dV times 1 over A plus 1 over V is equal to 0. So we know dV is less than 0, but dA is greater than 0, which means that dA over dV is less than 0. And we know in order to maintain a balance of the equation, so therefore d rho, which is the changing density here, must be greater than 0, which means that density is increasing. And these are the answers for this question.